Hi everyone, this is a review video for a topic suggested by one of the students, and well, you definitely don't have to watch this video if you have already know this topic, and and I'm gonna make this review video very short too. Okay, so the topic I'm gonna review is the median and the other statistics. So well, of course we know the median, but well, how about other statistics? So for the other statistics, it means that we want to know the S order statistic of an array. And we usually want to know that faster than the O n log n, because O n log n means we have to sort everything before we can pick the S value in the sorted array. We don't want to do that, and we want to do that in a faster way. And some of the special cases in the order statistics are the minimum. The minimum is the first order statistic, and then the maximum. The maximum is the nth order statistic, and then the median. The median is the n divided by 2 order statistic. So as long as we have an algorithm which can help us figure out any ith order statistic, and then the maximum, the minimum, and the median, they are just the special cases of that algorithm, right? Okay, and then well, to find the ith order statistic, and that is the selection problem. So we want to select the s order statistic, but we don't want to sort everything, and that is the challenging part, right? Because if we want to sort that, and then with O n log n we sort that, and then we just pick the s value from the sorted array, and then we have the selection problem sorted in the n log n. Well, we want to do that better, and the idea is we want to borrow the partition from the quicksort. So in the quicksort, and we pick a pivot, and after we have finished the partition, and what we will have is, say, if this q is the pivot, and then all the values on the left side to the q are the values smaller or equal to the q, and then on the right side those are the values greater or equal to the q, right? So this is the idea of the partition. If we borrow this idea, and actually we are able to come up with a average case ON algorithm. So this is the average case ON. And what we need to do is, well, this is a randomized select, and then we have the A. A is the list we want to do the selection on, and then for the P, this is the beginning index. R is the ending index, and then I is the ith order statistics we are trying to search in this area. Okay, so and what we are going to do is, well, we are going to borrow the randomized partition. So randomized partition, that is what we have done in homework 5, right? So after we have this randomized partition, and then we separate this data set into two parts, and after that we want to do a k. So this k is q minus p and plus 1. So this k is the value, this k is the value here. So well, this means, well, if from p to q with the p and q included, there are a total of k values. Okay, and then we want to do a comparison. So if this I is exactly the k, so this is the value we are looking for. So we just return the AQ because that is the order statistics we are looking for. And otherwise, well, and then we want to see if the I is in this range or the I is in this range. Okay, so if I is on this side, and then we want to narrow down the further search just for this side. So this is a recursive function cal, and we are making this recursive function cal. However, the search area will be from P to here. So here is the Q minus 1. Okay, so we only need to search from the P to Q minus 1, and then we are still looking for the ith order statistic. And on the other side, if we find that the I is greater than K, and then we are searching in this area, and then we are going to start from here, Q plus 1, and then the end of the search area is still R, and then we are looking for I minus K order statistic. So well, in this way, every round we are able to do a partition And after this partition, we can decide which way, left side or the right side, do we want to do the further searches on. Okay? And well, we can say on average case, and this is a all-in algorithm. Well, but if you go back to this code again, and if you want to consider the worst case, so what is the worst case? The worst case is, well, say if we want to do a partition here, and then we have the P, and then we have the R, and if we are very unlucky, we just pick this value as the Q. What is going to happen? If we just pick that value as a Q, so all the values are greater than the Q, all the remaining values are greater than the Q, right? So in this case, well, after this partition, it's very likely we are going to search the right side, and then on the right side we have n-1 value, and then we have to do another recursive call. So in the next recursive call, if we are unlucky again, so let me just copy this down. So now I have one value removed, so I have this one as a p-1, and then r is still the r, right? So in the next round, if I'm picking this pivot again, and we are really unlucky again, so every round we just reduce the search space by one item. So that is a super unlucky case. It's very unlikely to happen because we are doing a randomized partition. So it's very unlikely to happen. But well, arguably, in the worst case of this algorithm, this is a O(n) square algorithm. So why it is O(n) square? Because that's the same to the worst case of the quicksort, right? And then we say we want to do a worst case linear time selection, and now probably you still remember this, right? So the trick is we are trying to group the items into a tuple, the tuples of 5. So this one, let me change the color. So this is the tuple 1, 2, 3, 4, oops, 3, 4, and 5. Okay, so we have 5 tuples, and for each tuple we have 5 items, except for the last one. So if well, let's just say hypothetically the last tuple only has 4 items, so it will be like this. And then if we do an edge from a node to another node, and then we say A is smaller than B. Okay, so this is the rule of this graph. And by the way, this is also a directed graph, right? Okay, so this means, well, for each of if we we set up the problem like this, this means for each of the tuple we sort them from the low to high. Okay, tuple 1 low to high, and tuple 2 low to high. Okay, and after that we have 5 medians. Okay, those are the 5 medians. And after that, we grab those 5 medians and then we sort them again. So we have the median of the median. So this one is the median of the median. And after that, well, here is my observation. So if we have a trace of the nodes, say from A to B, and then we also have the B to C, okay? So if we have a trace from A to C, what does that mean? That means A must be smaller than C, right? Okay, so A can go to B, means A is smaller than B, and B goes to C, so B is smaller than C. So A can go to C, this means A is smaller than C. Okay, or A is smaller or equal to C. Okay, and with that being said, and what we will have is, if I draw such a box, so I call this box 1. Oops. This box 1 are the values smaller or equal to the median of the median. Okay, so and then if I draw this box, and this is the values greater or equal to the median of the median. Okay, so this is the trick. So and then we are doing the similar things that we do in the randomized partition. So decide it depending on which way we are going to search. Well, we can drop either all the values in this box or all the values in this box. So every round, it's roughly that we can drop 1/4 of the value. So we can cut down the search space by 1/4. So that is the worst case linear time algorithm. Okay, and this is the algorithm, and this is the analysis, and probably this is the hardest analysis of the algorithm we have ever seen in this class. So in the final exam, and there will be algorithm analysis for sure, but it won't be as hard as this one. And what you need to know is, number one, we have a average case linear selection algorithm. So you can if you want to do the tens smallest value in the array, and then we can do that without sorting all the values. And then we also have a very smart worst case linear time selection. So this is very tricky, and then you need to understand there is such an algorithm. I won't ask you to analyze an algorithm that hard, or and I won't ask you to design a algorithm that hard in the final exam, but you need to know this algorithm because this algorithm is really smart. Okay, so that is my first review video, and I hope I'm making that short enough. The reason I'm doing that is since we are in the coronavirus pandemic, we can't talk face to face, and if you have any questions, I can't really talk to you face to face, and I decide I want to make some review videos to help you learn. Okay, so that's it, and I will see you in the next review video. Bye.